Hello everyone! If you have seen this video, then you have chosen option 4. Dun dun dun! Let's do our reading. Forms of energy. Okay. You can follow along on the CK12 link or just listen ahead and watch what I'm looking at. 14.4 Forms of Energy. This musician's electric guitar wails at a concert as colored lights wash over the band. It's hot on stage because of the lights, but they really add to the show. Fans are thrilled and screaming with excitement. The exciting concert wouldn't be possible without several different forms of energy. Do you know what they are? Now, we're certainly not going to concerts, but that's one thing that I'm looking forward to once these lockdowns are restricted. Introducing forms of energy. Energy, or the ability to cause changes in matter, can exist in many different forms. We know that. We looked at a few last week. Energy can also change from one form to another. The photo above of the guitar player represents 6 forms of energy: mechanical, chemical, electrical, light, thermal, and sound. Another form of energy is nuclear energy and electromagnetic, but we will talk about that a little bit later. Can you find the 6 different forms of energy in the photo? Okay, so he's using mechanical energy to play the guitar. He's getting that energy needs from chemical energy, which is the food. Maybe he had some corn chips. The stage lights have the electrical energy going into them, which changed to light energy. And then he's probably sweating because that light energy brings with it thermal energy or heat. The guitar is producing sound energy through an amp when the guitarist plucks the strings. 7 forms of energy. They're defined here. Mechanical. It's the energy of movement. Is found in objects that are moving or have the potential to move. So it's kind of like a combination between potential and kinetic energy. Number 2, chemical energy is energy that is stored in bonds between atoms of compounds. If the bonds are broken, the energy is released and can be converted to other forms of energy. So easiest thing to think of is a battery, but something you might not think of would be food. Electrical energy is energy of moving electrons. Electrons flow through wires to create electric current. Okay, number 4, electromagnetic. That's the one that we had to get back to. It's the energy that travels through space as electrical and magnetic waves. The light flooding the stage is one type of electromagnetic energy. Others are radio, microwaves, X-rays, and gamma rays. We do not see them, but they're important in our lives. If you've ever broken a bone, I know you've gotten an X-ray, and heating up that hot pocket wouldn't be possible without a microwave. Thermal energy is the energy of moving atoms of matter. All matter has thermal energy because atoms of all matter are constantly moving, unless it's at 0 degrees Kelvin, which is absolute zero, and that's as cold as you can get. An object with more mass has greater thermal energy than an object with less mass because it has more atoms. Sound energy. If you noticed in my video last week, I was able to move that piece of toilet paper with a sound horn, a big amplifying horn that I'll put to good use some days. Sound energy is a form of mechanical energy that starts with a vibration in matter. For example, the singer's voice starts with vibration in his vocal cords, which are folds of tissue in his throat. The vibrations pass to surrounding particles of matter and then form one particular to another in waves. Sound waves can travel through air, water, and other substances, but not through empty space. Any idea why it's harder to hear? It's harder to speak underwater? Well, it's because those sound waves have to travel through water, and it's much easier to travel through air. Nuclear energy is energy that is stored in the nuclei of atoms because of the strong forces that hold the nucleus together. The energy can be released in nuclear power plants by splitting nuclei apart. It is also released when unstable radioactive material break down or decay. The fans at a rock concert also produce or use several forms of energy. What are they? The fans see, this is the people, not the twirling fans, see the concert because of electromagnetic light energy that enters their eyes from the well-lit musicians on stage. They hear the music because of the sound energy that reaches their ears from the amplifiers. They use mechanical energy when they clap their hands and jump from their seats in excitement. Their bodies generate thermal energy, dancing, and using the chemical energy stored in the food they've eaten. Okay, here's a short video going over some types of energy. It's just a basic summary. You can check it out. Energy, or the summary. I'll let you read those summary. But one of this review things is identify 3 different forms of energy represented by the trumpeter below us. So 3 different forms of energy. What do you think? Think about it. Think about it. Well, one is definitely sound. Then we have some mechanical energy because you can see his fingers are in motion. And there might be some thermal energy from the vibrations around his lips and all that friction caused there. So there's 3. There might be even more. All right, I'm going to jump to the next subchapter, which talks about energy conversion. So we started picking at this last week, but we're going a little deeper this week. Sari and Daniel are spending a stormy Saturday afternoon with cartons of hot popcorn and a spellbinding movie. They are obviously too focused on the movie to wonder where all the energy comes from to power their weekend entertainment. They'll give us some thought halfway through the movie when the storm causes the power to go out. I think they have 3D glasses on. I don't know anybody at home who has 3D glasses at a screen, but all right. Changing energy. Watching movies, eating hot popcorn, and many other activities depend on electrical energy. Most electrical energy comes from the burning of fossil fuels, which contain stored chemical energy. When fossil fuels are burned, the chemical energy changes to thermal energy, and the thermal energy is then used to generate electrical energy. Can you think of other ways, and probably better ways for our future, to generate electricity that aren't fossil fuels? Well, I did show you one. I have some solar panels installed on a garage next to my house, and so that would be solar energy, and another one would be wind. But there's a few others you can also investigate as well. Energy conversion is the process in which one kind of energy changes into another kind. When energy changes in this way, the energy isn't used up or lost. The same amount of energy exists after the conversion as before. Energy conversion obeys the law of conservation of energy. Okay? Which states that energy cannot be created or destroyed. Kind of like matter can't be created or destroyed. Everything that kind of happens on the earth stays on the earth. It's not really going anywhere else. The only thing that's entering the earth's system would be like an asteroid, which might be adding to the overall mass of the earth. But even if you have an explosion or a volcanic eruption, that energy isn't just going away. It's dissipating into different areas, and eventually it could make its way all the way back to the same source in which it came from. How energy changes form. Besides electrical, chemical, and thermal energy, some other forms of energy include mechanical and sound. Any of these forms of energy can change into any other form. Often, one form of energy changes in two or more forms. For example, the popcorn machine below changes electrical energy to thermal energy. The thermal energy, in turn, changes to both mechanical energy and sound energy. You can read the figure below to see how this happens. So it's taking electricity to heat up probably the bottom of that pan, which heats the popcorn. The corn explodes. Then the corn moving, I guess, pushes out of the top of the popcorn and it falls down. Okay. And then it can give me some tasty popcorn energy. Kinetic potential energy changes. Mechanical energy commonly changes between kinetic and potential energy. Kinetic energy is the energy of moving objects. Potential energy is energy that is stored in objects, typically because of their position or shape. We know this. This is from last week. Come on. Kinetic energy can be used to change the position or shape of an object, given it potential energy. Potential energy gives the object the potential to move. If it does, the potential energy changes back to kinetic energy. Whew, that's a lot of energies in one paragraph. Don't worry. Let's go through an example together. That's what happened to Sari. After she and Daniel left the theater, the storm cleared and they went for a swim. That's Sari in the picture down here. When she was at the top of the water slide, she had the most potential energy. Why? Because she had the potential to slide down into the water with the pull of gravity and the slipperiness of the slide. As she moved down the slide, her potential energy changed to kinetic energy. And by the time she reached the water, all the potential energy had changed to kinetic energy. So how could she regain her potential energy again? Well, she could, just like resetting a roller coaster, the wild thing at Valley Fair, my favorite. You got to go back up, except you got to use some kinetic energy to climb those steps to go to the top. And that energy is going to be stored up there when she gets up there. And by the time she's up there and she goes down, process starts over again. Can you think of other fun examples of energy changing between kinetic and potential? Well, I'm upstairs in the second floor of my house right now. So there's one example. Playground equipment, swings, slides, trampolines. Yeah, you all know some. Energy transformation video. This one just has a lot of text and goes through a bunch of examples. If you find another more compelling thing, something on YouTube, then send it my way. Maybe I'll like it more than this one. Okay, energy conversion is the process in which energy changes from one form or type to another. It's always conserved. It doesn't disappear. It just changes. Okay. Different forms of energy, electrical, chemical, and thermal, often change to other forms. Mechanical energy commonly changes back and forth between kinetic and potential energy. Okay, so if we're in, they have one of these review questions is on the one I chose, but if you're done option 4, then you've watched my read through. And I want you to explain the law of conservation of energy in your own words. Why is this happening? What does it mean? And what is an example in your daily life? Okay, then we have our 7 types of energy here. I listed them all for you. Just give me an example. Okay, there's got to be something that you can think of when I say sound. On the next slide, it says, explain how energy changes back and forth between kinetic and potential energy when you jump on a trampoline. Include a sketch to help explain the energy conversions. So just like that slide and that they were talking about the change from potential to kinetic, give me a diagram, give me some stick figures, show me what's going on when I'm going. If you don't want to use a trampoline, then just do another system with somebody or something. All right, I hope this helps. Look forward to reading your responses, and thanks for listening.